differential equation is taken. Now, this differential equation is the higher order differential equation with constant coefficient, or the linear differential equation with the constant coefficient. And we have already seen this type of equation in the last video. So guys, if we have assumed this equation, then how to find out the solution of this equation? So for any higher order differential equation, the solution is given in two parts. So I'm going to write down that solution. So its solution is given as y equal to yc plus yp. Now guys, you must be thinking, what is yc and what is yp? So yc is complementary function and yp is called as particular integral. So I'll write here for you. Now guys, yc and yp are the symbols used by me for simplicity, but in many colleges they say complementary function as cf and particular integral as pi. So they take the initials and they say the complete solution or the final solution of higher order differential equation is cf plus pi. But here we will call it as yc and yp. So in our case, yc is complementary function and yp is the particular integral. Now the question remains how to find out the value of yc and yp. So guys, let's understand how to find out the solution or how to find out the value of yp. So guys, this is the formula to find out the yp. So you can see here I have written it is 1 upon f of d multiplied by x. So let's understand what does it mean. So this x is nothing but our right hand side. So this is the right hand side and this f of d is nothing but the function of d. Now you must be thinking how to find out that function of d. So guys, whenever we get any higher order differential equation to find the solution, that time we replace the terms like dy by dx by capital D into y. So I'll show you that thing. So on screen you can see that dy by dx is written as capital D into y. So this capital D is called as operator and its value is d by dx. If your differential equation is in terms of y and x. Next, d square y by dx square. It's the second order derivative of y with respect to x. So it is denoted as d square y. And guys, if I ask you what is d cube y by dx cube, then you can properly say that it is d cube y. Yes. So similar terms, if we get in the equation or the higher order differential equation, we can replace it by d raised to 4y, d raised to 5y and so on. So when you replace these terms with this dy, d square by d cube y, your equation, or I would say this left hand side, would be the function of d. So for that, I'll take one example quickly. So let's assume one higher order differential equation. This is the higher order differential equation with constant coefficient. So let's apply the rule. So according to rule, we'll replace this d cube y by dx cube by d cube y. Then this 3 as it is. We'll replace the d square y by dx square by d square y. So it's d square y minus 2 as it is. This will become dy plus 4y equal to sine of x. Now guys, from left hand side we can take y common, and in the bracket we'll get so it means this equation has got converted in the form of function of d into y equal to sine x, which is our capital X. So guys, let me tell you that any higher order differential equation, when you replace that dy by dx with dy or d square y by dx square as d square y, it gets converted into this form, which is f of d into y equal to x. And guys, that f of d is present here along with y, and that f of d you have to consider while finding the value of yp. So when we are finding the value of particular integral, that time I'll be taking that f of d over here, and I will multiply this x, or I will apply this operator on the x. So x is nothing but the right hand side. So this x can be any function of x. So this is how we find out the value of yp. Now you must be thinking then, sir, how to solve this? So to solve this, there are different 7 types, and in each type the solution differs. So we are going to cover that method of solution of those 7 different types in the coming videos. So let's come back to the solution part. So y is given as yc plus yp complementary function plus particular integral. We know how to find out yp. Now let's move to the yc. Now the question is how to find out the yc, and for this guys I have steps with me. So the steps to find out the yc always remain same. So let's follow the steps to find out the yc. So in this video we are going to see the different steps which we use to find out the yc, and then in the next videos we are going to solve few numericals in which we will find out yc by applying these steps. So keep patience and be attentive, because these steps are very important, and if you understand these steps, then only you will be able to find out the value of yc in the any higher order differential equation. So here are the steps. So step number 1 is we have to find out the auxiliary equation. So what is the auxiliary equation? It is f of d equal to 0. It means whenever you equate that f of d to 0, that is called as auxiliary equation in higher order differential equation. So guys, here we have learned how to find out f of d. So that value of f of d we are going to equate with 0 to get the auxiliary equation. Then step number 2, we are going to find out the roots of auxiliary equation. So guys, let me tell you, the f of d that we get is always the equation, or it is in the form of equation. So that equation can be a cubic equation, that equation can be a quadratic equation, or that equation can be any degree 4 equation. So what we have to do is we just have to find out roots of that equation by the general methods of solution of equation, and those roots we have to observe. So now there are 5 different methods to find out the yc. So method number 1, if the roots that we get from f of t equal to 0 are real and distinct means different, then the solution is as below. So here I have taken one example. Here I said that the roots are like a, b and c. So guys, remember that when you solve this f of t equal to 0, your left hand side would be d and right hand side will be the roots. So let's assume that these roots are real and distinct. So in this case, what will happen? The solution is c1 into e to the power ax plus c2 e to the power bx plus c3 e to the power cx plus so on. It means whatever are the real roots, you just have to write those roots as a power of e along with x. So A, B and C here I've written, and this C1, C2, C3 are just the general constant. This is a method to find out the YC if the roots are real and distinct. So now one more thing you have to observe here, that here I've considered three real and distinct roots. That is why I'm getting three constants and three terms. So tomorrow if you have two roots, then you will be having only two terms, or if you have four roots, you will be having four terms. So this is the first type of solution to find out the YC. Now the question is, what if the roots are not real and distinct? I mean to say, if the roots are real and repeated. So guys, this comes under the different category. So let's understand how to find out the YC in that case. So if your roots are real and repeated, here I have taken one example. Let's say roots are A and B. So A is repeated, but B is distinct. So whenever we have repeated roots, what do? We write the solution as C1 plus C2x into e to the power ax, plus B is a non-repeated root or the distinct root. So that the solution for that will be same as the previous steps. So it is C3 into e to the power bx. So in the previous method, to find out the YC for distinct roots, so that method will be applicable over here for B. Now let's observe the root A. So here that root A is repeated two times. So guys, what I've done here, so here I've considered this e to the power ax only once, because that A is repeating two times. So here I have taken one bracket, and inside the bracket I have written two constant, that is C1 and C2. So one constant will remain as it is, and for the second constant I am multiplying with x. So what exactly we are doing? So it means that whenever we have any repeated root, let's say if it is repeating three times, so in the bracket there will be three constants, C1, C2 and C3. So first constant will keep it as it is. For the second constant will multiply with x, and for the third constant will multiply with x square. So the power of x will increase. So that example I have taken here. Let's say now there are five roots, that is A and B. So both roots are repeated. A is repeated three times, B is repeated two times. So in this case, let's see what happens. So this e to the power ax, that is first root. Now A is repeating three times, hence in the bracket I have written three constants, C1, C2, C3, and with that I have written nothing, that is constant 1, x and x square. So it means every time we have to increase that power of x. So let's say tomorrow if we have four roots, then we will have one more term, that is C4 into x cube, and so on. Now here B is repeated two times, so e to the power bx here, and in the bracket we have written C4 plus C5x. Because it is repeated two times, I have two constants. But guys, remember one thing, as here I have used C1, C2, C3, here I am gonna use the different constant. So that is why here I am using C4 and C5, and I am multiplying that C5 with x. So this is the method to get the YC if your roots are real and repeated. Now case number 3, it means your roots are not real. So those roots might be the complex roots. So that is the case number 3. If the roots are complex and distinct, that is different. So here I have taken the example, the roots are like a plus or minus ib and c plus or minus id. So guys, here you can observe there are four roots. First one is a plus ib, then a minus ib, then c plus id, c minus id. All four roots are different. So what is the solution in this case? So let's see. So yc is given as e to the power ax into, now guys, e to the power ax means this power of e is always the real part. So real part in a plus ib is a, so that will go here. Now in the bracket we have written two constants c1 and c2. So with c1 we have cos term, with c2 we have sin term, and with that we have b. So b is the imaginary part. So what you have to remember? You have to remember like this, that the real part of that complex number will be outside the bracket as a power of e, and the imaginary part will go inside the bracket as a angle of cos and sin. So that is the solution. Now same thing I have applied for c plus id and c minus id. So here c is the real part, so that will become e to the power cx, and in the bracket d is the imaginary part, so that will go as the angle for cos and sine. So that will become c3 cos dx plus c4 sine dx. So guys, that is the solution. Now in this also there is one variation. It means if the given roots are complex but repeated, it means here I have taken one example, that is a plus or minus ib, a plus or minus ib. Now guys, here you can observe one thing, that the root a plus ib is repeating 2 times and the root a minus ib is repeating 2 times. So what is the solution? See here. So that time e to the power ax. So real part is a in both the cases. So that will come outside as e to the power ax. Now since the roots are repeated, what we'll do is that imaginary part will go with cos and sine, and since the root is repeated twice, here we have written c1 plus c2x and c3 plus c4x, which we have seen in the previous method. So whenever root is repeated 2 times, we have to write down 2 terms with 2 constant, and the second constant will be multiplied by x. If the root is repeated 3 times, then we'll be saying c1 plus c2x plus c3x square. So we have to add that term, and that cos term and sine term will remain as it is. So guys, this is the solution when the roots are complex and repeated. Now apart from this, there is one more case. Now you must be thinking, what is that case? So guys, as we can get real roots, as we can get complex roots, similarly we can get real and irrational roots. Now you must be thinking, how does it look? So real and irrational roots look like this: a plus or minus root b. So you can see that this is real. If I add a with root b, I'll get some real number, or if I subtract this root b from a, I will get one real number, but this root b is irrational. So this is called as roots are real and irrational. So in this case, what is the solution? So this solution matches with the solution of complex number. So here this real part, or I would say both are real numbers, but the number which is outside the root is a, so that we will take as a power of e, and the number which is inside the root, or that irrational part, we will take it as the angle of hyperbolic cos and hyperbolic sine. So here instead of cos and sine, we'll be having hyperbolic cos and hyperbolic sine. So the solution is e to the power ax c1 hyperbolic cos root bx plus c2 hyperbolic sine root bx. So guys, here I am also taking root along with b. So you have to remember this. Then I have taken one more example where I have repeated that real and irrational root. So the root is like a plus or minus root b and a plus or minus root b. So here the root a plus root b is repeating 2 times, and the root a minus root b is repeating 2 times. So what is the solution? So answer is e to the power ax, that is the this constant a, and that irrational constant which will be inside with hyperbolic cos and hyperbolic sine. But since this root is repeating twice, we will be taking 2 terms, that is c1 plus c2, and we'll multiply that c2 with x, that is c1 plus c2x, and with this we'll write c3 plus c4x as we have done in the previous method. So guys, these are the 5 different types of solution are possible for complementary function. So whenever we want to find out yc, which is complementary function, we get the roots in one of these 5 cases. So what you have to do is you have to observe the roots, check where it belongs to. If it belongs to case 1, we have to apply that formula. If it belongs to case 2, we have to apply that formula, and so on. So this is how we find out the value of yc and yp, that is complementary function and particular integral. So I'm sure that you understood how to find out the solution of any given higher order differential equation with constant coefficient. So guys, the first thing you have to do is you have to subscribe to this channel, because through Ekeeda channel we are trying to spread the engineering education and the science education with all the students. So subscribe to channel to show your love and support, and don't forget to forward this video to your friends, because if they are also doing engineering or science, they should get this beautiful video done by me and other professors of Ekeeda. Thank you very much.